in this video also we will continue with the problems related to the chapter electricity. Next question is, several electric bulbs designed to be used on a 220 volt electric supply line are rated 10 watt. How many lamps can be connected in parallel with each other across the two wires of 220 volt line if the maximum allowable current is 5 ampere? So many electric bulb or electric lamp is connected in parallel to a 220 volt supply line. Maximum current passing through that circuit is 5 ampere. Maximum current passing through that circuit is 5 ampere and the potential difference is 220 volt. Power of one bulb is 10 watt. Power of one bulb is 10 watt. So, how many bulbs can be connected in parallel to that circuit? Okay, what's the total number of bulbs connected in that circuit? So, potential difference is given as 220 volt. Current is given as 5 ampere. So, we will find the maximum power of that circuit. Maximum power of that circuit using the equation P equal to V I. Maximum power, that is 220 volt into 5 ampere. 220 volt into 5 ampere. So, you will get the answer like this. Okay. The answer is 1100 watt. That is the maximum power of that circuit. Okay. Now, one bulb is having a power of 10 watt. One bulb is having a power of 10 watt. Maximum power of that circuit is this much. So, maximum power equal to number of bulbs into power of one bulb. Maximum power is equal to number of bulbs into power of one bulb. So, when we got maximum power as 1100 watt, we know the value of power of one bulb, 10 watt. So, watt equal to, let n be the number of bulbs into 10 watt. So, you will get the answer like this. N is equal to watt divided by 10 watt, that is equal to 110 bulbs. So, this much bulb can be connected to that circuit. Okay. So, how we did it? We find the maximum power from the equation P equal to V I. Then maximum power is equal to number of bulb into power of one bulb. Power of one bulb is also given in the question 10 watt. So, 1100 watt equal to n into 10 watt. So, n equal to 1100 watt divided by 10 watt. So, you will get 110 bulbs connected in that parallel combination. 110 bulbs are connected in that parallel combination. Different methods are there to do this problem. I selected only one method to do this problem. Okay, using the equation P equal to V square by R, we can also solve this problem. Okay. Next question. Yeah. 3 resistors of 2 ohm A, B, C are connected as shown in the figure. Each of them dissipate energy and can withstand a maximum power of 18 watt without melting. Find the maximum current that can flow through the 3 resistors. Okay, 3 resistors are there. The value of 3 each one is 2 ohm. They are connected in this way. First, 2 resistors are connected in parallel, then a 2 ohm resistor is connected in series to that combination. Let I current will flow through the first resistor. It will divide it into 2 equally and will flow through B and C, and at this point it will again combine together to form as a single current and it will complete the circuit. So, what is the current flowing through the circuit? Okay, what is the current flowing through the 3 resistors? Means how much current will flow through A resistor, how much current will flow through B and C. Here the current flowing through B and C will be equal. It will be equal. Now, how to do this one? Let I be the current flowing through the circuit through 2 ohm. Let I be the current flowing through 2 ohm. Now, the power is given as 18 watt. The power of the combination is given as 18 watt. Then the resistance is given as 2 ohm. Okay, I is the current flowing through this 2 ohm resistor. So, P equal to I squared R I square equal to P by R, or I equal to root of P by R, that is equal to root of 18 by 2, that is equal to root 9, that is equal to 3 ampere. That is equal to 3 ampere. So, 3 ampere current will flow through 3 ampere current will flow through this resistor 2 ohm. 3 ampere current will flow through this 2 ohm resistor. Then at this point, this 3 ampere current will divide equally and 1.5 ampere will flow through this one, 1.5 ampere will flow through this one, and here again 3 ampere current will flow. Okay. So, current flowing through 2 ohm is 3 ampere. Here that at this point that current will divide into 2 equal parts, because B and C is having equal resistance. So, 3 by 2, it is 1.5. So, 1.5 ampere will flow through this 2 ohm resistor, 1.5 ampere will flow through this 2 ohm resistor, and at this point again this 1.5 and 1.5 will add it together and 3 ampere will flow through there. Okay. So, three ampere current will flow through 2 ohm resistor, that is represented by the letter capital A. 1.5 ampere current will flow through. Other resistors, that is B and C. 1.5 current will flow through B and 1.5 current will flow through C. Okay. Now we need to complete this table. That is, the resistance of the conductor is given as R, intensity of the current is given as A, the time for which the current is flowing, that is given as T. As per Joule's law of heating, H is equal to I squared R T. Now, what will happen when we increase the resistance, increase the current, increase the time? What will happen when we decrease the resistance, decrease the time, decrease the current, and decrease the time? What will happen to the heat developed? So, first one I will do it and the rest you have to complete it. So, here using the equation H is equal to I squared RT. So, H is equal to, instead of I it's also I square, instead of R it's 2R, the resistance is 2R. So, 2R, time is T. So, here 2 into I squared R T. So, what is the change in the heat energy? The heat energy is increased twice. Heat energy is increased twice. So, the increase is twice. So, 2H heat is 2 times the heat is developed. Okay, as per this equation, 2 into I squared R T. So, that much change in the heat will be there. So, direct way you can substitute and you can find the other answer. Complete the table. Next one is, an electric heater of resistance 8 ohm draws a current from the main in 2 hours. Calculate the amount of heat developed. Okay. So, R is equal to 8 ohm, I equal to 15 ampere, then T equal to 2 hours. So, that hour should be converted into seconds. That hour should be converted into seconds. Then use the equation H is equal to I squared R T. H is equal to I squared R T, and substitute in this equation and you will get the answer. Here time should be in seconds. Next problem. 2 conducting wires of the same material and of equal length and equal diameters are first connected in series and then in parallel in an electric circuit across the same potential difference. What will be the ratio of the heat produced in series and parallel combination? So, what is the heat produced when 2 resistors are connected in series? The same 2 resistors are connected in parallel. So, what is the heat developed in that case? Find the ratio. Okay. So, series in case of series two resistors are there that's connected in series. Suppose this one is having a resistance R, this one is also having a resistance R. Now the effective will be Rs equal to R plus R, that is equal to 2R. That is equal to 2R. Now, what is the heat developed in this case? So, heat developed in series, we will write it like this, that is equal to, we use the equation V square T by R, because it is given in the question same potential difference. So, we will write the equation V square T by R, and we will substitute here and find the answer. We will substitute here and find the answer. Now, for the parallel one, two resistors are connected in parallel. This one is also having a resistance R, this one is also having a resistance R. Find the total resistance in this case. Find the total resistance in this case. 1 by Rp equal to 1 by R plus 1 by R, that is equal to 2 by R. Rp equal to R by 2. Rp equal to R by 2. Now, heat developed in the parallel combination of these two resistors, we will write it as Hp, heat developed in the parallel combination, that is equal to V square T by R, that is equal to V square T by this Rp, so R by 2, and here we will write it Rs, H is equal to means heat developed in the series combination, so equal to V square T by R, that is Rs, we will write it as Rs, that is equal to V square T by 2R, V square T by 2R. Name this as equation 1. And this as equation 2. Name it as equation 1 and 2. Now, we need to find the ratio. Or 1 divided by 2, equation 1 divided by equation 2. Okay. So, we will write it like this, V square T by 2R, V square T by R by 2. We will write the ratio as like this, V square T by 2R, V square T by R by 2. So, when you do the calculation, you will get the answer as like this, V square T and V square T will get cancelled, R and R also will get cancelled. So, you will get the value like this, that is equal to 1 by 4. The ratio will be equal to 1 by 4. The ratio will be equal to 1 by 4. So, in series it is 2R. So, we will get the equation like this, V square T by 2R. In parallel the effective is R by 2. So, we will get an equation like this, V square T by R by 2. You just compare the ratio, equation 1 by equation 2, heat developed in series divided by heat developed in parallel. When you do the substitution and you do calculation, cancellation, you can cancel V square T, here also V square T, this R and R will get cancelled. So, it is 1 by 4. Okay.